So, if we have a chemical reaction happening and we know the mass of one substance in an equation, we can use it to calculate the mass of the other components. This is called stoichiometry, particularly mass-mass stoichiometry, because we're starting with mass and we're ending with mass. To do it, you need two things. You need a balanced equation and you need the ability to calculate amount in mole. So if you can do both of those things, which you should now be able to, then you can do mass-mass stoich. 4 steps. Step 1, you write your balanced equation, because that tells us the ratios that we need. Okay? That tells us how many particles of your reactants give you how many particles of your products. You then calculate the amount in mole of the substance that you know about. So your reactant, say, you know how much of it you've got, you calculate the amount in mole of it. Then you use what we call the mole ratio in the equation. That's those big coefficients that you use to balance the equation. That tells us, we say, how many particles of reactants make how many particles of the products. And from that, you can find the amount in mole of the substance that you're making. And then finally, once you've got its mole, its amount, then you can find its mass. So let's look at an example. Okay, we've got some iron, it's going rusty, it's making iron oxide. First thing I'm going to do, I'm going to balance this equation. Okay, so I've written my balanced equation, I made sure I checked all my formulas, I've put my coefficients in, it's balanced. You can check if you want, but I assure you it is. Step 2, I'm going to use that 70 grams of iron, I'm going to divide it by the molar mass of iron, just one of them. Doesn't matter that my equation says 4. The molar mass of iron from the periodic table, 55.85 grams per mole. And that gives me 1.25 moles. It's got some more decimal points. I'm just going to leave that on my calculator. I'm not going to round it yet. Then I'm going to use my mole ratio. So if I look at my equation, if I've got 4 moles of iron, then that's going to give me 2 moles of iron oxide. I'm looking at these big coefficients. Okay, 4:2 ratio. So if I've got 1.25 moles of iron, it's going to give me half as many moles of iron oxide. So I'm going to divide it by 2, gives me 0.63 moles, and a few other decimal points, and I'm still not rounding that, of iron oxide. And then finally, I'm going to rearrange, and I'm going to find from the moles of iron oxide, I'm going to find its mass. So I'm going to take that moles, I'm going to multiply it by the molar mass. So it's going to be 2 irons plus 3 oxygens, which gives me a molar mass of 157.9 grams per mole, which gives me an overall mass of 98.95 grams. And now finally, you're allowed to round it to 99 grams.